Today we will learn the shortest job first scheduling algorithm by using the preemptive approach, which is the shortest remaining time first. So now what is the shortest remaining time first algorithm? So here, if the CPU burst time of the new process, which is arrived in the ready queue, if it is shorter than the current executing process, that is the process which is currently utilizing the CPU or which is present into the run state, then in the preemptive version, it will stop that process and it will start executing the newly arrived process. So this is the shortest remaining time first algorithm. So when the process is preempted from the CPU or from the run state, then your context switch process, it will save the current state of the process which is currently utilizing the CPU. Then that process is preempted and again it is placed into the ready queue. But now how this preemptive approach it is used by the shortest job first algorithm. So in that case, the it compared the CPU burst time of all the processes which are present in the ready queue and the process which is currently utilizing the CPU. And if the processing time or burst time is smaller, means if the processing time or burst time of the process which is arrived in the ready queue, if it is shorter than the process which is currently utilizing the CPU, then your CPU scheduler it will preempt the process which is currently utilizing the CPU and it will assign the CPU to the new process whose burst time is smaller than the current process. And if the two processes have the same execution time, then jobs are based on first come first serve basis. So here you will understand this concept when we will solve the problem. That what is the preemptive approach. Okay. So this is the table which is given. Arrival time of each process is given and burst time is given. So from this table now we will draw the Gantt chart. So let us consider these four processes now and now we will consider their arrival time. Okay. So the shortest job first algorithm it uses the criteria of burst time, whereas first come first serve algorithm it uses the criteria of arrival time. So here it compares the burst time of all the processes which are present in the ready queue. So in this table you can observe that process P1 it entered into the ready queue at 0 time unit. Now here only four processes are given and here you can observe that no other process is there which is entered in the ready queue at 0 time unit. So only one process is arrived at 0 time unit. So we will represent the ready queue now and we will shift this process P1 from this table into the ready queue. So we'll draw the ready queue for this. So see what I am doing here. Take out this process P1 from this table and now that process P1, it goes into the ready queue. Now here I am representing the ready queue like this. That is arrival time of that process. Then ready queue. In the ready queue, I am representing the process identification number that is process P1, P2. So many times only numbers are given instead of giving the variables that is P1, P2. Instead of that numbers are given 1, 2, 3, 4 that are nothing but the process identification number and burst time. So total time required to complete its job is equal to 5 time units. So you draw this ready queue. By representing the ready queue here, that is at 0 time units, the process P1 it is entered into the ready queue. So draw this. Then I will explain you that how to draw the Gantt chart. So the process of drawing the Gantt chart is very important. Once you will understand this Gantt chart, then you can easily solve any type of scheduling problem. So tell me, once you will finish your drawing. Okay. Now see, I am drawing the Gantt chart. So process P1, only one process is entered into the ready queue at 0 time unit. So here we will represent the Gantt chart. On the left hand side of this square or rectangle, I am representing the arrival time of that process. See, this is very important. Here in that rectangle, I am representing the process P1. That is process P1, it is entered into the ready queue at 0 time units. So left hand side number, it is representing the arrival time of that process. This is the arrival time. Okay, P1 entered into the ready queue at 0 time units. But now here in the non-preemptive approach, once the processor is assigned to the process, that processor it will exit from the run state only when it will finish its job. Suppose अभी ये non-preemptive algorithm है. So how your non-preemptive algorithm will work? So P1 it entered into the run state, and now if it entered into the run state, it requires 5 time units to complete its job. So it will execute its job, and then at 5 o'clock it will exit from the run state. Okay, suppose now this process P2 it entered at 1 o'clock, then it will complete its job. That is total 3 hours are required to complete the job for the process P2. So it will complete its entire job, then only it will exit from the CPU. So this is the preemptive approach. This is the non-preemptive approach, but now we are solving this problem by using the preemptive approach. तो अभी preemptive approach में हमें क्या करना है? So what we will do here, process P1 it entered into the run state at 0 time unit. So now we will execute that process P1 only for 1 time unit. See, this is very important. I will execute this process P1 only for 1 time unit. So on the right hand side, I will represent that number. That is process P1. It has executed only for 1 time unit. So अगर process P1 ने 1 time unit complete किया है, so total time units required to complete its job is equal to 5 time units. अभी 5 में से 1 time unit उसने complete कर लिया अपना job. So now how many time units are remaining for the process P1 to complete its job after 1 time unit? 4. Okay, see. So what I am doing here, see it very carefully. On the ready queue, what I am doing here. सो 5 टाइम यूनिट्स 1 टाइम यूनिट का जॉब उसने अपना कंप्लीट कर लिया, मतलब प्रोसेस P1 का भी कितने टाइम यूनिट्स बचे हैं? 4. तो मैंने क्या किया, वो स्क्रैच किया नंबर 5, वहां पे मैंने रिप्रेजेंट किया 4 कि अभी प्रोसेस P1 इट विल रिक्वायर 4 टाइम यूनिट्स टू कंप्लीट इट्स जॉब. Okay, now why I am doing this? So why I am executing that process P1 only for 1 time unit? Because here after every 1 hour, if you are representing it at that 1 o'clock, 2 o'clock, 4 o'clock, so now at 0 time unit process P1 entered and at 1 o'clock process P2 entered. तो जब process P1 ने 1 time unit complete कर लिया, so here you can observe that at 1 o'clock process P2 it entered into the ready queue. So B, what we will do here, now we will shift the, what we will do here, key process P2 it entered at 1 time unit. So now we will shift this process P2 from this table into the ready queue. Okay, बिकॉज यहाँ पे P1 ने 1 टाइम यूनिट का जॉब कंप्लीट कर लिया, अभी यहाँ पे 1 o'clock हो गया. तो यहाँ पे इस टेबल में हमें चेक करना है कि 1 o'clock में कोई प्रोसेस अराइव हुई है रेडी क्यू में या नहीं. तो 1 o'clock के यहाँ पे 3 प्रोसेसेस रिमेनिंग है, तो 3 प्रोसेस में सिंपली 1 प्रोसेस इज देयर विच इज अराइव्ड एट 1 o'clock. So what I will do here, I will take out this process P2 from this table. So here I will scratch that process, and then that process it is shifted into the ready queue. So arrival time for the process P2 is 1 time unit, and in the ready queue the another process is entered now, process P2, and the total time units required to complete its job is equal to 3 time units. Okay, इसके बाद now see, this is the shortest remaining time next algorithm. We are using the shortest job first preemptive algorithm. तो अभी हमने यहाँ पे क्या किया है कि प्रोसेस P1 को सिंपली 1 टाइम यूनिट हमने असाइन किया था, उसने अपना जॉब 1 आवर के लिए कर लिया. अभी 4 आवर्स आर रिमेनिंग फॉर दिस प्रोसेस P1. अभी रेडी क्यू में हमारी सिर्फ 2 प्रोसेसेस है, प्रोसेस P1 और P2, ओनली 2 प्रोसेसेस आर देयर, एंड हियर वी आर सिलेक्टिंग द प्रोसेस फ्रॉम द रेडी क्यू डिपेंडिंग ऑन इट्स बर्स्ट टाइम और प्रोसेसिंग टाइम. तो अभी प्रोसेस P1 का कितना टाइम बचा है? 4 टाइम यूनिट्स, और प्रोसेस P2 को कितना टाइम बचा है? 3 टाइम यूनिट्स. So now what it will do, your shortest job first algorithm, it will check the burst time of the processes which are present in the ready queue. So ready queue में सिर्फ P1 and P2 है, तो यहाँ पे it will select that process from the ready queue which will require the shorter burst time. It will select the process P2 from the ready queue because it will require 3 time units to complete its job. So now your CPU scheduler it will select this process P2 from the ready queue and it will assign the processor to that process P2. So now what I will do, I will represent that process P2 into the Gantt chart. But now see, what I will do, I will not execute that process P2 completely. Though it will require 3 time units to execute, as this is the preemptive algorithm, what I will do, again I will assign only one time unit to process P2. Means that process P2 it will execute only for 1 hour. Only for one time unit it will execute. Because आपको हर एक वन टाइम यूनिट के बाद चेक करना है कि इस टेबल में कोई ऐसा प्रोसेस तो नहीं है कि जो रेडी क्यू में अभी एंट्री जिसने किया है. एंड आफ्टर दैट यू हैव टू चेक इट्स बर्स्ट टाइम ऑल्सो. So what I will do here, I will assign only one time to process P2. So process P2 it will execute for one time unit. तो यहाँ पे प्रोसेस P1 ने 1 o'clock को वो एग्जिट हुआ था और P2 प्रोसेस ने एंट्री लिया रन स्टेट में एट 1 o'clock. Now that process P2 it will execute only for 1 hour. So now it will exit from the run state or from the CPU at 2 o'clock because मैं सिर्फ वन टाइम यूनिट को प्रोसेस P2 को CPU असाइन कर रही हूँ. Okay, so now process P2 it will execute its job only for one time unit and right hand side में उसका completion time is that process P2 is not completed yet, it is executed only for one time unit. तो अभी रेडी क्यू में आपको क्या करना है, यहाँ पे ये 3 स्क्रैच करना है बिकॉज टोटल बस टाइम उसका कितना था, 3 टाइम यूनिट था. अभी उसने उसमें का वन टाइम यूनिट यूटिलाइज कर लिया. सो अभी हमें क्या करना है कि प्रोसेस 3 कट करना है. एंड नाउ द टाइम रिक्वायर्ड फॉर द प्रोसेस P2 इज टू सी हियर दिस इज द रेडी क्यू. अभी मैंने क्या किया, 3 स्क्रैच किया और यहाँ पे मैंने 2 रिप्रेजेंट किया क्योंकि प्रोसेस P2 अभी तक कंप्लीट नहीं हुआ है. सो 2 टाइम यूनिट्स आर रिक्वायर्ड फॉर द प्रोसेस P2 टू कंप्लीट इट शॉप. अभी इसके बाद हमें क्या करना है, हमें इस टेबल में चेक करना है कि 2 o'clock को कोई प्रोसेस अराइव हुआ है टेबल रेडी क्यू में या नहीं. So here you can see that process P1 it is already shifted from this table into the ready queue. P2 ने भी यहाँ पे हमने shift किया है into the ready queue. Now process P3 it is arrived at 2 o'clock. यहाँ पे 2 time unit को process P2 ने exit किया. So process P3 it arrived at 2 time units. So what we will do now? यहाँ से हम process P3 को निकालेंगे. So we will shift that process P3 from this table into the ready queue. तो अभी हमें यहाँ से ready queue में shift करना है. So process P3 it goes into the ready queue. Arrival time of that process is 2. रेडी क्यू में P3 प्रोसेस है और उसका टोटल CPU एग्जीक्यूशन टाइम कितना है, 4 टाइम यूनिट. अभी इसके बाद क्या करना है, हमें यहाँ पे हमें चेक करना है कि as this is the shortest job first algorithm we have to check which process will require the shortest time, a smaller time or shorter time to execute it short. Process P2 from the ready queue and we will assign the CPU to that process P2 again. यहाँ पे 2 टाइम यूनिट को 2 o'clock को उसने एग्जिट किया था लेकिन यहाँ पे फिर भी रिमेनिंग बर्स्ट टाइम इसका 2 स्मॉलर है, शॉर्टर है. सो दैट्स व्हाई अगेन वी आर असाइनिंग द प्रोसेसर टू द प्रोसेस P2. सो फिर से हमने प्रोसेस P2 को टाइम असाइन किया है, CPU असाइन किया है. तो अगेन नाउ वी विल एग्जीक्यूट द प्रोसेस P2 ओनली फॉर वन टाइम यूनिट. और ये कब तक आपको करना है दैट ऑल्सो आई विल टेल यू. सो नाउ वी विल एग्जीक्यूट दैट प्रोसेस P2 ओनली फॉर वन टाइम यूनिट. सो अभी यहाँ पे उसका कंप्लीशन टाइम क्या होगा, 3. Okay, so process P3 it will execute only for 1 hour or one time unit. So P2 को हमने 3 टाइम यूनिट्स, तो यहाँ पे अभी 3 o'clock हो गया है. ओके तो इसके बाद हमें क्या करना है कि हमें देखना है कि अभी प्रोसेस P2 का कितना एग्जीक्यूशन टाइम बचा है, बर्स्ट टाइम बचा है. तो जब उसने इसमें एंट्री किया था दैट टाइम द टोटल बर्स्ट टाइम वाज रिक्वायर्ड फॉर द प्रोसेस P2 इट वाज 2. लेकिन अभी उसने वन टाइम यूनिट एग्जीक्यूट कर लिया, तो अभी हमें क्या करना है, 2 स्क्रैच करना है. तो हाउ मच टाइम इज रिमेनिंग फॉर द प्रोसेस P2 नाउ, 1. तो यहाँ पे मुझे 1 लिखना है. ओके तो 1 लिखना है. अभी हमें ये टेबल चेक करना है कि इस टेबल में चेकआउट वेदर एट 3 o'clock एनी प्रोसेस इज अराइव्ड इनटू द रेडी, बिकॉज ओनली वन प्रोसेस इज रिमेनिंग P4. उसका अराइवल टाइम क्या है, 4 टाइम यूनिट है और 4 o'clock को उसको एंट्री करना है CPU में. तो 3 o'clock को तो कोई भी प्रोसेस नहीं है जो जिसने रेडी क्यू में अराइव किया है और जिसने रेडी क्यू में एंट्री लिया है. सो व्हाट वी विल डू नाउ, अभी तो 3 o'clock है, ये प्रोसेस तो 1 घंटे बाद आने वाली है रेडी क्यू में, तो हमारे पास अभी भी 1 घंटा बाकी है. सो इन दैट 1 hour नाउ यू कैन यूटिलाइज द CPU. So what we will do now, we will compare the burst time of P1, P2 and P3. So this is the, it will assign the processor to process P2. Okay, so we will assign the processor to process P2. So it will execute only for 1 hour. वैसे भी अभी process P2 को कितना टाइम बचा है, 1 टाइम यूनिट. फिर भी हमें जब तक all process will not entered into the ready queue, we will execute all the process only for one time unit. This is very important statement. So see what I will do here, I will assign the processor to process P2. तो अभी हमने process P2 को CPU assign किया. Okay, तो यहाँ पे process P2 को CPU assign करने के बाद it will complete its job and then here the finishing time will be 4 o'clock. ओके, तो 4 o'clock हुआ है. तो अभी इसके बाद हमें क्या करना है, देखना है कि P2 का कुछ बर्स्ट टाइम रिमेनिंग है या नहीं. सो व्हाट आई विल डू नाउ, I will cut that one. So now the total burst time required to complete its job is 0. तो यहाँ पे process P2 is completed. That is process P2, it has finished its execution, so it will enter into the terminate state. So I will write down here that process P2 is completed. Okay. So now that process P2 is not present in the ready queue as well as it is not present in the run state, it enters into the termination state. लेकिन अभी हमें क्या देखना है कि यहाँ पे ये फिनिशिंग टाइम है प्रोसेस P2 का. तो अभी हमें टेबल में चेक करना है कि कोई प्रोसेस है रिमेनिंग जिसने 4 o'clock को एंट्री लिया है रेडी क्यू में. यस, सो यहाँ पे प्रोसेस P4 it has entered into the ready queue at 4 o'clock. तो अभी हमें क्या करना है, now take out this process P4 from this table and assign ready queue that to that process. So that process it entered into the ready queue. So it is 4 time unit. P4 it is arrived in the ready queue at 4 time unit and total execution required for that process execution time required to finish its job is 1 time unit. So it will select the next process, that is process P4. So process P4 it will select. So P4, then again I will execute. Now see, here you can see that all the processes are entered into the ready queue. उसमें से आपका process P2 complete हो गया है. So in this ready queue only 3 processes are there, process P1, P3 and P4. तो यहाँ पे let us consider that instead of 1 time unit, this process P4 it required 2 time unit to execute its job. तो यहाँ पे हम compare करेंगे 4, 4, 2. Then also you will assign the CPU to process P4 only. Now once all the processes will enter into the ready queue, there is no need to assign the CPU only for 1 time unit. After that you can execute that process completely. You can utilize that process completely, processor completely until that process it will finish its job. So what we will do now, process P4 it required 1 time unit to execute its job. So here on the right hand side we will represent the finishing time, that is 5 time unit. 5 o'clock को process P4 it will exit from the CPU or from the run state. So what we will do now here, one I will scratch that one, remaining time is 0. So I will represent that process P4 it is completed its job. So now here you can observe that only 2 processes are there, process P1 and P3. तो P1 का भी remaining burst time है 4 time unit और P3 का भी burst time है 4 time unit. तो यहाँ पे अगर burst time same here to do, you have to select the process on first come first serve basis. So I will assign the CPU to the process P1. Okay. Yes, arrival time की means by using that first come first serve basis or by using the arrival time you will select the process if their burst time is same. So in that case now I will select the process P1. Will be the completion time for the process P1. Yes, it is 9. Yes. After that now here process P4 मतलब 4 कट करना है आपको और यहाँ पे 0 रिप्रेजेंट करना है. So now again at the last now only one process is there, so process P1 is also completed. So I will write down there process P1 is completed. So now I will assign the processor to the last process, that is process P3. So abhi only one process hai, so again we will execute it completely. So it will be yes, so it is 30. So P3 is 30. So 13 o'clock or 13 time unit ko all the processes are completed. So this is your Gantt chart. From this Gantt chart now we will calculate the remaining value and cut that 4 here, write down 0 and then write down completed. Okay. So now ready queue is empty. Its meaning is that all the processes, processor it is assigned to all the processes. From this Gantt chart now we will calculate the different times which are asked in the question. So at first we will find out the completion time. तो completion time क्या होता है? From this Gantt chart we will find out the completion time. Completion time ये अराइवल टाइम है और जो राइट हैंड साइड का टाइम है दैट इज रिप्रेजेंटिंग द कंप्लीशन टाइम. कैन दिस टेबल फ्रॉम लेफ्ट टू राइट, जो राइट हैंड साइड में प्रोसेस है उसी का आपको राइट मोस्ट नंबर लेना है. तो प्रोसेस P2 को P2 ने कंप्लीट किया 4 टाइम मिनट, इट हैज कंप्लीटेड इट्स जॉब एट 13 टाइम मिनट्स एंड P4 ने 5 टाइम. इट इज द टर्न अराउंड टाइम, कंप्लीशन टाइम माइनस अराइवल टाइम. तो 9 minus 0 It is 9, 3, 11, 1. Okay. Yes. After that, waiting time. So turnaround time minus burst time. 4070. Yes. Then at the last here, we will check the response time. See, up till now we have studied that in the non-preemptive approach, the waiting time and response time is same for all the processes. But now here the waiting time and response time, it is different for the preemptive approach. So now see what is the response time for these four processes now. So what is the formula for that? That is response time, it is equal to CPU for the first time. That is the process. It will get the CPU for the first time. उस टाइम से we have to subtract the arrival time. प्रोसेस P1 को प्रोसेसर कब मिला है? अभी हमें हमें यहाँ पे लेफ्ट हैंड साइड नंबर देखना है 0. 0 टाइम यूनिट पे उसको फर्स्ट टाइम प्रोसेसर मिला है, तो वो 0 टाइम यूनिट में से हमें अराइवल टाइम सब्सट्रैक्ट करना है. सो 0 माइनस 0, सो दैट इज 0. P2 को सीपीयू सबसे पहले कब मिला है? 1 टाइम यूनिट पे, तो आपको क्या करना है? 1 माइनस 1. ओके, 1 माइनस 1, अराइवल टाइम तो उसका 1 टाइम यूनिट था, सो दैट इज 0. को एट व्हाट टाइम the CPU, yes, at 9 o'clock को प्रोसेस P3 को at 9 o'clock the CPU is assigned. एंड उसका अराइवल टाइम क्या था? वो तो 2 o'clock को ही उसने एंट्री लिया था रेडी क्यू में, लेकिन उसको CPU मिला 9 o'clock. सो व्हाट आई विल डू? 9 minus 2, दैट विल बी 7. P4 का, तो P4 ने 4 o'clock को एंट्री लिया है एंड उसको CPU मिला है 4 o'clock को, तो उसका कितना हो गया रिस्पॉन्स टाइम? Yes, 0. So 4 minus 4, 0. So here you can observe that the response time and waiting time is different if you are using the preemptive approach. See, average waiting time is 2.7, then average turnaround time is 6. Yes, it is 6 and throughput is 3.25.